720 million years ago, our planet transformed into something almost unrecognizable. Earth, once a vibrant world of oceans and continents, became sealed under ice from pole to pole. Imagine standing at the equator and seeing only endless glaciers with sunlight bouncing off a frozen shell. The entire planet turned into a giant snowball drifting through space. This wasn't just an ordinary ice age, it was the most extreme freeze in Earth's history. For millions of years, oceans lay buried under kilometers of ice. Storms tore across barren surfaces, and survival seemed impossible. Yet, deep beneath the frozen crust, life endured. Fragile microbes and the earliest multicellular organisms clung to existence in hidden sanctuaries. Their resilience not only allowed them to outlast this catastrophe, but also prepared the way for the future of evolution. This is the story of Snowball Earth, a time when our planet nearly died, but in the process, life learned how to fight back.
Beneath the endless sheets of ice, life faced its greatest trial. To imagine this world, picture a frozen ocean stretching for thousands of kilometers. The surface is sealed by kilometers of solid ice, reflecting back sunlight and locking the planet in darkness. Above the ice, storms howl across lifeless plains, but below, hidden in the blackness, life clings to existence. Microbes, the most ancient residents of Earth, had already survived billions of years of change. Now, they faced their ultimate test. Deprived of sunlight, they could no longer rely on photosynthesis, the process that once fueled the planet's ecosystems. But life has always been resourceful. In cracks beneath the frozen crust, where volcanic activity warmed the ocean floor, hydrothermal vents became lifeboats for survival. From these vents poured scorching minerals, rich in energy. Around them, bacterial colonies thrived, not from sunlight, but from chemical reactions. These organisms used sulfur, iron, and methane to power their existence, a strategy called chemosynthesis. Instead of basking in the warmth of the sun, they grew in the glow of Earth's inner fire. It was a hidden world, teeming with life, even as the surface froze into silence. But how could life remain diverse in such harsh isolation? Scientists believe shallow pools of liquid water might have existed near volcanic islands, kept warm by geothermal activity. In these rare sanctuaries, simple multicellular organisms may have survived. Fragile, microscopic creatures with bodies made of only a few cells. Imagine tiny sponges or primitive colonies of algae surviving like candles in a storm. Their survival was not guaranteed. Every day brought starvation, extreme cold, and the threat of extinction. Yet the few that endured became the ancestors of all complex life. It was in this crucible of ice and darkness that evolution hardened its resolve. Modern evidence supports this extraordinary survival story. In ancient rocks, scientists have discovered chemical signatures of photosynthesis during the Snowball Earth period, suggesting that somewhere, small refuges of sunlight broke through the ice, allowing algae to persist. Perhaps thin spots in the ice let in faint rays of light, just enough to keep photosynthetic life barely alive. It was not abundance, but endurance that mattered. These microbes and early multicellular organisms clung to existence with the tenacity of survivors, waiting out millions of years of global freeze. And when the world finally thawed, their resilience would shape the destiny of evolution. Snowball Earth was not just an age of ice. It was a test. And life passed that test, emerging scarred but unbroken. Without these hidden survivors, the story of animals, plants, and eventually us might never have begun.
For millions of years, Earth remained locked in its icy shell. But beneath this frozen silence, forces were building. Volcanoes scattered across continents and ocean floors never stopped erupting. Every eruption released invisible plumes of carbon dioxide into the atmosphere. Normally, rain and oceans absorb this gas, but in a snowball Earth, oceans were sealed under kilometers of ice. There was no cycle to wash it away. Instead, greenhouse gases accumulated, slowly and relentlessly. Year after year, century after century, the air above the ice grew thicker with carbon dioxide. Earth had turned into a vast pressure cooker, waiting for the moment to break free. Eventually, the greenhouse effect reached its tipping point. The planet could no longer contain its heat. Temperatures began to rise, ever so slightly at first, but enough to start melting the edges of the ice sheets. Cracks appeared, rivers formed on the glaciers, and pools of liquid water spread across barren surfaces. Each drop of melted ice exposed darker rock, which absorbed more sunlight, accelerating the thaw. Then came the flood. Glaciers collapsed with thunderous force, releasing torrents of water across the continents. Oceans swelled as ice sheets disintegrated. For a planet frozen for millions of years, the thaw was violent, a global transformation from white to blue. But this was not a gentle warming. With so much carbon dioxide trapped in the atmosphere, Earth didn't just thaw, it boiled. Temperatures soared to extremes, creating a hothouse planet. Torrential rains lashed the land, storms battered the oceans, and the environment shifted from an icy desert to a chaotic furnace. The scars of this upheaval remain carved into Earth's rocks. Ancient deposits show layers of glacial debris buried suddenly beneath thick carbonate stone. Evidence of ice sheets melting into warm seas filled with new chemistry. These rocks are time capsules, capturing the violence of a planet breaking free. For life, this shift was both a crisis and an opportunity.
Organisms that had endured the deep freeze now faced scorching heat and new chemistry in the oceans. Many perished, unable to adapt quickly, but those that survived emerged stronger, better suited to handle extremes. This evolutionary pressure reshaped biology itself, setting the stage for the rise of more complex life. The story of Snowball Earth is not just about survival under ice, but also about enduring fire after the thaw. It is a reminder that Earth's greatest catastrophes often pave the way for its greatest transformations.
The thawing of Snowball Earth was not the end of hardship. It was the beginning of a new struggle. The planet had gone from deep freeze to blistering heat in only a geological instant. Oceans surged with fresh chemistry. Rains carried torrents of dissolved minerals from the land, and the balance of Earth's systems shifted dramatically. For the organisms that had endured millions of years in icy refuges, this sudden shift was both terrifying and transformative. Many perished in the chaos of warming seas and violent storms, yet those that survived encountered a world rich with opportunity. The meltwater carried a flood of nutrients into the oceans, creating chemical soups where new life strategies could evolve. This surge of nutrients fueled blooms of photosynthetic organisms. Algae spread across the seas in massive waves, harnessing the sunlight that had been denied for millions of years. For the first time, oxygen levels in the atmosphere began to climb higher, reshaping the air and oceans alike. With more oxygen came the possibility of larger, more complex bodies. Life could finally afford to grow. The survivors of Snowball Earth became pioneers of complexity. Early multicellular organisms diversified, no longer confined to fragile colonies in shallow pools. They began to experiment with form and function, branching bodies, differentiated cells, and new ways of feeding and surviving. Tiny sponges, delicate filaments of algae, and primitive animals began to carve their place in the newly thawed oceans. But this was more than an evolutionary step. It was an evolutionary leap. The environmental pressures of global freeze followed by a catastrophic thaw acted like a furnace of innovation. Organisms that adapted thrived, while the weak vanished. This sharpening of life's edge laid the groundwork for the Cambrian explosion, a period not far in the future when life would burst forth in unprecedented diversity. The rocks left behind tell us this was a turning point. Carbonate deposits formed after the ice melted record the sudden influx of life-sustaining elements. Fossils of early multicellular creatures appear soon after, suggesting that the evolutionary fuse had been lit. Snowball Earth, once seen as a global disaster, now appears as a necessary trial, a reset button that forced life into resilience and creativity. This is the paradox of catastrophe. It destroys, yet it also transforms. Without the extremes of Snowball Earth, perhaps life would have remained simple, microbial, and stagnant. Instead, the planet's greatest freeze and its most violent thaw prepared the stage for complex animals, plants, and eventually, us. When we look back at this chapter in Earth's story, we see more than ice and fire. We see a crucible of evolution,
a trial by extremes that shaped the destiny of life itself. Snowball Earth was not just survival against odds, it was the spark that ignited the journey toward complexity.
The tale of Snowball Earth is less a closed chapter and more a scientific battleground. What looked like an apocalyptic freeze may have nearly wiped out life, or, as some argue, made complex life inevitable. The paradox is striking. Microbes clinging to existence in cracks of ice and hydrothermal vents became the ancestors of all higher forms. When the planet finally thawed, the nutrient surge and oxygenation fueled the evolutionary engine that set the stage for animals, ecosystems, and ultimately humans. Yet, not all scientists agree on how global this snowball truly was. Paul Hoffman and Joseph Kirschfink championed the theory of a fully frozen planet, while critics like Richard Alley and William Hyde suggest a slushball Earth, where equatorial waters remained open, challenging the extremity of the freeze. Was it total entombment or partial resilient zones that preserved life? The debate still rages. And this raises a provocative question. If Earth hadn't plunged into such extremes, would evolution have taken the same course? Or, more controversially, did life need catastrophe, ice, fire, and chaos to reach the point where intelligence could emerge? In the end, Snowball Earth wasn't just a trial of survival. It was a crucible that forced transformation. Whether frozen solid or partially spared, it remains one of the most radical resets in Earth's history, and perhaps the very reason we are here to argue about it today. Do you agree with Paul Hoffman or support more for Richard Alley? Give us your thoughts in the comment. Thank you for watching, and we will see you soon in the next episode.